So let's continue here with example 3, solving using substitution. All right, so I have 3x plus y equals 5 and 3x minus 2y equals negative 7. Neither one of these equations has y equals or x equals. That's always what you're looking for, x equals or y equals. However, if I rewrite this first equation, I can get y equals pretty easily. If 3x plus y equals 5, if I subtract 3x from both sides, y equals negative 3x plus 5. Now, if y is equal to negative 3x plus 5, I can take negative 3x plus 5 and substitute it in the other equation right there. So we know that 3x minus 2y equals negative 7. But everywhere I see a y, I'm going to put in negative 3x plus 5. Bring down the equals and bring down the negative 7. Now I'm going to distribute the negative 2, so I get 3x. Negative times a negative is positive 6x. Negative times the negative is a positive. Negative times a positive is negative equals negative 7. Let's combine our like terms. 3x and 6x becomes 9x minus 10 equals negative 7. And we want to solve for x. So we'll add 10 to both sides. And we get 9x equals 3. And then since we want to get x by itself, we'll divide both sides by 9 and reduce. 3 over 9 is equal to 1/3. So now I have a value for x, but I'm only halfway done. I'm going back to this equation. I've got this really nice equation that will give me a value for y if I know x. So y is equal to negative 3. I'm going to substitute in my value that I have for x, 1/3, plus 5. So 3 goes into 3 once. Negative 1 times 1 is negative 1 plus 5. So y is going to equal 4. And what's my neat way of shorthand x equals 1/3, y equals 4? The ordered pair, 1/3, 4. And again, you can check your answer. Substitute 1/3 in for x and 4 in for y for both of your equations to check your own answer. All right, go ahead and try practice 3. Moving on to example 4, this is the worst possible scenario for substitution. Here I have my system of equations and neither equation starts with x equals or y equals. So if I have to rewrite one of these equations, which one should I pick? I'm going to pick this one because I have a 1y. You want to try to find the equation that has a 1x or a 1y. This is the equation I'm going to rewrite. Negative 3x plus y equals negative 1/3. Let's add 3x to both sides. Y equals 3x minus 3. This value for y, 3x minus 3, is what I'm going to substitute in the other equation. So let's try it. 5x minus 2. I'm not going to put y. I'm going to put what y is equal to. 3x minus 3. And that's going to equal 6. Distribute the negative 2. So I have 5x minus 6x plus 6 equals 6. 5x minus 6x is negative x plus 6 equals 6. And let's subtract 6 from both sides. So I get negative x equals 0. And I don't want a negative for x. Oh. I don't want a negative for x, so I'm going to change the signs. And 0 doesn't have a negative or a positive, so x is equal to 0. Halfway done. I go back to this equation, and I can get a nice value for y if I know x. Y is equal to 3 times, if x is 0, y is going to equal 0 minus 3, or negative 3. And the nice shorthand way of writing x is 0, y is negative 3 is as an ordered pair. All right. So we've seen solving systems graphically. That was 4-1, and now we've been solving using substitution. And we've been finding the point of intersection. We've been finding the solution. Here I actually have y equals 1/3 x plus 2. So I'm going to take y equals 1/3 x plus 2 and substitute that in for y. Negative x plus 3y is going to equal 6, which means negative x plus 3. I'm not going to put y. I'm going to put what y is equal to. 1/3 x plus 2 is equal to 6. So now I'm going to distribute the 3. Negative x plus x. 3 times the third is 1. Plus 6 equals 6. Well, negative x and positive x is going to cancel, so I'm going to get 6 equals 6, which is always true. Do you remember when we learned to solve linear equations with one variable, if we came up with something that was always true, we would say there's an infinite number of solutions. If you come up with something that is always true, it's an infinite number of solutions. What that means is these are really the exact same line. These are equivalent lines. If we were to graph these, they would be right on top of each other. So you can get a single solution. If in solving using substitution you get a universally true statement, that means there's an infinite number of solutions. And then let's take a look at, oh, you know what? Why don't you go ahead and do practice 5. Practice 5.